Oh, what's this? I'm almost on time or something like that. I know, imagine my shock. Hey guys, what's going on? Memes here. And yes, we're gonna be delving into a little bit of some stuff and things that we've talked about before. Now we're being a wee bit more forward, let's say, about what might be going on. Why? Well, let's get straight to the point. So apparently there's this thing within particle physics called the hierarchy problem. What is the hierarchy problem? Well, it originally was, why was the mass of the electron so much smaller than the proton mass? And apparently we managed to figure a bunch of that stuff out. We're still not necessarily sure, but at least we have some potential answers. But now the current hierarchy problem, at least within the greater YouTube space, you'll hear, is why is the mass of the Higgs boson so much smaller than the Planck mass? Why is this? Because at the Planckian energy scale, we consider the Planck mass to be a 1. Okay. Why? It is a maximum 1 because if you cram a Planck mass into a Planck volume, you're essentially going to create a black hole. Okay. So none of that, as far as I know, is controversial. But we're going to get a wee bit heretical here. Yes, I have the Winnie the Pooh, good at doing absolutely nothing. Why? Well, I feel like it's a representation of a little bit of the principle of least action. Okay. Now, we may see in coming times that there may be some other principles of action, but let's just focus on the principle of minimal or least action right now. What is this? Well, apparently, in order to help solve the ultraviolet catastrophe or whatever you want to call it, Max Planck, according to legend, in a moment of desperation, is like, what do I actually have to do to make this work? And he found there was a particular wavelength and combination of different things that seemed to actually work, ultimately developing h, Planck's constant, and subsequently h divided by 2 pi, or one rotation or cycle, if you would, h bar, Planck's reduced constant, aka the elementary unit of action. Why am I talking about the elementary unit of action if I'm supposed to be talking about the Higgs boson? And as we know, we had lost Peter Higgs last year, and then one of his other collaborators had passed away before that, and he had actually been the individual that had made the prediction that, oh, you should find something here, and it was somewhere between, I don't know, like 80 to 100 to like 160-ish GeV. There were some more calculations that put it in the range of about 126.5 GeV, and then now with more recent measurements, it seems to be right about a little bit more than 125 GeV. What the heck is a GeV? That's a giga electron volt. It's basically a measure of energy. Okay, so the unit of energy, you could say it in joules, you could say it in GeV, but that's why a lot of times you'll see that whole, here's a mass expressed in energy, and they'll put that little c squared over it, divided by c squared, because remember, thanks to good old Albert Einstein, we get E equals mc squared for the approximate rest mass of different things that we know as particles. Groovy. Okay, so there's a concept called naturalness, in that many people would expect the Higgs boson to be of the magnitude of the Planck mass. So let's actually, while folks are getting it, hey, Poindexter, good to see you, my friend, good to see you. We'll erase some of our other blasphemous stuff here, and then we'll get right into it, and we'll lay it out step by step so that basically the folks at home can actually play around. And you don't gotta believe me, but this is a conjecture that I like to colloquially call the Planck boson and Joule conjecture, which ends up abbreviating to the PB&J conjecture. Why? Well, because if any of this actually ends up being relevant and you needed to teach it to people, you want something people can remember it by. What are you going to call it? Like the memes transformers? Okay, maybe that would be kind of cool, but I think since there's a long history of physicists being among some of the greatest trolls in history, citation, Professor Feynman and his antics, and as well as some other folks that came up with the tortoise coordinate for black holes and stuff. It's like the symbol is literally a turtle. I'm like, wait a second, are they literally inferring turtles all the way down? I mean, let's face it, nobody would ever do something to be silly. But, all right, let me grab a marker. So the whole question is, and part of this is practice for me, because I recently posted a clip from the Demystify Psi podcast, or excuse me, Demystify Psi's Paradigm Drift. So basically that's where they literally, you sign up, they throw a bunch of names in a hat. If you get drawn, you have 1 minute to pitch your idea or your theory, and then basically you'll have about maybe 10 or 15 minutes interview with Anastasia and Shiloh, as well as any of the other guest panelists that they happen to have on there about what might be going on. This is an attempt to bring some more heterodox ideas, if you would, into the limelight, because you never know where a good idea may come from. So now again, this is conjecture. Let's play our Professor Wolfram clip so we can cover our butts as we over here. All right, as we conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
All right, I had to double check. I'm like, did I misspell hierarchy? It looks like I spelled it correctly. All right, so let's write this on the board. So, oh God, I am the worst speller. It literally was like my worst subject. All right, so, all right. I already forgetting I before E except after C, except when it isn't. All right. Hierarchy problem. All right. So as we get folks joining us from all across the internet, we'll write this stuff on the board. So whether you're coming from the YouTubes, the Twitters, where the skies are blue, the Facebooks, yada, yada, yada. All right, we're going to be discussing the hierarchy problem. Let's see if I can minimize a little bit more of that glare. All right, well, that didn't really help, but it's okay. It's okay. So the hierarchy problem is, at least to my understanding, this has been shared with me. Again, I'm not a trained particle physicist or anything. I'm a dude on the internet. And again, I could be wrong. That's why we're conjecturing. We're laying out the P, B, and J conjecture. All right. So why am I calling this? Well, because basically, at least for this calculation that I claim may give us a little bit more intuition about what's going on with at least why the Higgs boson takes the mass it does. Again, I'm not trying to say, oh my God, this is the reason why we have electroweak breaking between the strong force electromagnet, blah, 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 blah. No, I'm not saying that. I'm just going to present a very simple calculation that seems to have really dang good agreement with at least the most recent measurements. Okay, so why am I calling it? It's because it's got a Planck thing in it. It's about a boson. And you're expressing in energy, which the base energy is joules, even though we usually use GeV, because PB and G conjecture doesn't sound as good as PB and J. So we can say things so that it's true, and it's also a mnemonic, because at least I grew up trying to remember the 9, when we had 9 planets, as my very educated mother just showed us 9 planets. That stuck with me today so I can remember. If all of a sudden you have something like a PB and J conjecture, it's like, oh, I can remember that. What is it? Oh, it's got something to do with the Planck stuff, boson stuff, and Joule stuff. I just think it's kind of neat, and I'm also a troll. So, full disclosure here. Listen, we all have different identities. Gamer and troll are among some of them. And then guy that pretends to do scientific stuff on the internet. All right, so the hierarchy problem is, why is Y is the Higgs mass. Higgs mass so much smaller than the Planck mass. Then I'm going to use the terminology we're going to do M sub, I'll do big P for sakes, just because the Planck mass, okay. Because Planck is the name of somebody, so we use a capital letter. Why? I don't know, respect and just standard, that's what I learned. All right, so the Planck mass is about, I think it's about roughly of magnitude, it's 10 raised to the 9 giga electron volts. It's like 2 times 10 or 1.956, something like that. GeV, and then we're going to do that divide by c squared. Okay, so here's our question. This is essentially the Planck mass, basically. Ginormous number, because a giga electron volt is 1 billion electron volts. For reference, basically a proton is about 1 giga electron volt. It's like 938 mega electron volts, so roughly it's about 1 GeV. So proton, I'll just write proton. Proton is about 1 GeV, and I'll throw in the divide by c squared, just so we're being accurate here. Okay, because of mass, energy, and energy equals mass. And we can do that little conversion by the speed of light squared. Okay, so here's the question. Why the heck is the Higgs boson so much smaller than the Planck mass? Okay, it's about 17 orders of magnitude. Why? Because the Higgs, we'll do M sub H, big H for Higgs, and that's about 125 GeV. So the divide by c squared, so get it accurate. All right, so 10 to the 9, that's about 1 billion times more. To be fair, okay, it's about 100 million times more. Oh, that's actually interesting. Okay, I'm realizing this now with the stream of thought. It's about 100 million times larger. I'm just saying that because for those of you that have been following the channel for a little bit, I've been conjecturing about the size, or at least the maximum amount of size and stuff within what we colloquially call universe. Okay. Basically, the whole conjecture is, well, if we have a minimum, which as far as we know is the Planck length, according to modern physics and stuff and things that we know, okay, so if we were to invert that would be a logical framework utilizing maximal extendability, in that we would have our realm be as big as possible in a logical way. So the whole claim, and this is what I had gotten from that, so this isn't me at all, it was more like, all right, well, if we had a minimum, the Planck length, then if we had a maximum, it would be the inverse of that, which is a ginormous number. Long story short is the general calculations come out to be about 100 million times larger than our current observable universe. Okay, so our observable universe on scale is about 10 to the 26 meters. What is that? That's a billion, like 100 million meters. That's freaking ginormous. It's freaking redonkulous, if you would. That may or may not be a technical term for it. Okay. So that's why I found that interesting. But that's not what we're talking about today. Okay, so what we're talking about today is, why the heck is the Higgs boson about 100 million times smaller than the Planck mass? Actually, to be fair, it is Let me make sure I have this right, because it's actually 17 orders of magnitude, and that doesn't sound right. Hold on, I need to double check my calculations before I just start spitting all this other stuff here. Hey, Tommy, good to see you. I saw you over there at Loki's. Yep, no, we're just going over a little science stuff and things so that if ultimately anyone brings it up, because you may have heard the thing like, what the heck is a Higgs boson? Well, if you've ever heard people talk about the God particle, this is what they're talking about. Why? Because I think Professor Michio Kaku wrote a book saying that, calling it literally the God particle. Okay, I'm realizing right now I didn't even put an N on the proton. Proton mass. All right there. I'm sorry, Bald. It's one of those things, like when I start watching videos and stuff, and like that's kind of how I got into this, because as much of a dumpster fire as the Dr. Eric Weinstein, Sean Carroll debate was, in my opinion, Dr. Weinstein, when he was on Joe Rogan, he was talking about spinners and stuff. It's like, well, they happen to go around twice to get around the same side, back to the position. You're like, that's blowing my mind. He does that. What was it, like the Peruvian wine dance? It's like, well, how do you get this all the way around? It's like, you go like this. How do we keep going? Oh, we go under, we go over, and then we loop back around. Fantastic. All right. It's also an excuse to drink some coffee. So now that I've finished imbibing some of the nectar of the gods, let's continue to talk about the quote-unquote God particle. All right. So basically, this is a ridiculously big number. That's a ridiculously small number. And here's the thing. I just wrote some things on the board. Let's go to our good friend Wolfram Alpha. So, because again, that whole trust but verify. And if anything, don't trust me at all. It's just, don't believe me. Believe your lying eyes. And again, I'm not saying that this is the solution, because many things, there are different ways you can come about it. That's why when you hear folks talking about a quote-unquote theory of everything, number one, I'm not trying to explain everything. I'm just looking for a framework that would help explain the phenomena that we have. So basically, as Professor Wolfram might say, is a fundamental theory of physics. Okay. And we do have the standard model right now, so you'll hear terms like U1 cross SU2 cross SU3. So what the heck does that mean? All right, the whole U1 is electromagnetism. And the fascinating thing, I think it might be Richard Beale, or there was another YouTuber on here. Basically, electromagnetism literally comes out of mathematics. We get it for free. It's still trying to blow my mind, but apparently, if what was it? U1 is probably, we had Faraday, and then we had, oh my God. I'm sorry, hold on. I need to give credit to somebody. Electromagnetism. Not the spectrum right now. It was Faraday, and then, oh God. See, this is why history 19th. Maxwell. There we go. All right. James Clerk Maxwell. So basically, you get the whole Maxwell equations, yada yada, and stuff. And basically, there were mathematicians. Like if people just kept doing math long enough, they would have found it as well. So basically, electromagnetism we get for free. SU2 is basically for the symmetry of the electroweak force, and then once you get to SU3, that's basically the strong force. That's what we're modeling. All right, so we're trying to model electromagnetism, the electroweak force, and the strong force, and then whatever the heck gravity is. Okay, so let's see. Oh, we got comments here. Tommy's commenting, believe none of what you heard and half of what you see. Well, it's becoming harder and harder with the internet. We're getting better and better video generation as whatever Google's next little thing where they're adding the things where you got the owl flying around, it's talking to a badger, and then all of a sudden a squirrel hops by. It looks really cool, and people have pointed out that our technology is getting much, much greater. And then Tommy's commenting, the conceptual ideas of today could quickly become the defunct theories of tomorrow. I mean, that's kind of what history has said, because I think it was Thad that told me that, what was it? If somebody's not calling you crazy, you're not making progress. Now, to be fair, you might just be crazy. Now, full disclosure, I am crazy. I literally identify as a crazy person on the internet. I'm wearing a fucking Pooh Bear t-shirt and freaking getting my new level up shirts and stuff like that. But a lot of the times you'll find, and oh God, at least throughout history, what you'll see is somebody postulates a new idea. All right. And a lot of times if it's a new idea and people aren't familiar with it, it's like, bad. I mean, what is it? Bruno or one of those early folks that were proposing things, I think he got burnt at the stake or something like that. Usually not as bad now, but you have the digital versions of that. Not that, again, the means of destruction channel does not promote violence unless we were to legalize dueling and let consenting adults engage in mortal combat under the doctrine of bodily autonomy. It's a personal opinion there. Okay. But, see, that's the thing. And it's one of those things, like, I at least on Twitter over the past few days, folks going around saying, oh, physicists haven't done anything for like 75 years. It's like, really? Really? They haven't done anything? It's like, oh, well, it's not like the electronic devices we're on was made possible by our understanding of the world and everything. And listen, you go back in the day, what are we doing? We're literally remote viewing right now. That's supposed to be an impossible thing, but as we've learned from Arthur C. Clarke, any sufficiently advanced technology is indistinguishable from magic. Cool. But, all right. Hey, Rosalie. Okay, so Rosa's saying they're listening to the book, The Business of Belief by Tom Asker. Oh. Let me say this. What is that called again? The Business of Belief. Let's see. The Business of Belief. Okay. Let's just check this out real quick, because this is interesting, because I kind of went into the scientific space to kind of get away from the whole politics thing when I realized I'm like, a lot of people don't really seem to want to solve problems. They just want to fight with folks that they don't like and then dunk on them. Why? Because, listen, people can do whatever they want. That's up to them. I'm sure a lot of people aren't doing it just because of money or something like that. All right, so the business of belief, how the world's best marketers, designers, salespeople, coaches, and fundraisers, and educators. Oh, wow. That's, I might have to get this. Get us to believe. Okay. So real quick side story on this. I spent about a decade in corporate sales. My job was to separate a customer from as much money as possible. Not always, but typically it's kind of like a lot of things online. The job of an online company that's selling anything is to basically separate you from your money in as few clicks as possible. I remember when Amazon turned on its one-click purchase thing, and I was a little skeptical. I'm like, oh, it has to have a confirmation. And that's how I ended up with an extremely expensive, full like elite replica Smoking Skull Stone Cold Steve Austin Championship belt. It's a beautiful, literal, full replica. The thing is heavy as heck. I did not need to spend anywhere near that much money on that. It was not necessary at all, but I was skeptical about one click, boom. I'm like, well, there goes a lot of my money. That was a personal failure on my part. I should have believed in that instance. But, so that's one of those things where they teach people professionally. And in a lot of corporations, there's literally scripts. So like, if you've been on the phone with a lot of these companies, you'll notice you can tell people are literally just reading from a script, or they're going through a canned response or something. Why? Because there's a whole bunch of really smart people that work for that company that have found that this is the best way to go about things. I remember there was one company I worked for where it's literally, you need to memorize basically word for word It's like 1-page script to go through and say all these words and just talk for like 4 or 5 minutes explaining why the person that just met you should spend, I don't know, like $20,000 or $30,000 on a particular home improvement project with a person they've never met. Now, and they tell you it's like, logically, no person is ever going to sign a contract with somebody they just met after a couple of hours for $20,000 or $30,000, unless you take them through an emotional roller coaster. You bring them up, you bring them down, you bring them up, bring them down, to literally the point like, oh my God, I need this right now. And that's what a lot of these places will teach you, or at least from my experience. Now, again, how do we get on this tangent again? All right, David, welcome, my friend. Good to see you. I saw you over at little Loki's over there. Good to see you around here. No, we're just talking about the business of belief. Maybe I will get into some of those things. It's kind of like anytime you see a video that starts off with the truth about a thing. Personally, I tend to think that that's probably not the actual truth about the thing. Why? Because nobody would express their opinion as fact on the internet. That's just something to think about. Now, it's very, listen, when people are saying things that you want to hear, it's very easy to just gobble that up. And that's what the algorithm will drive you towards. So let's wrap this back around to the whole science thing is, a lot of times you'll find like, there'll be names of like different physicists and stuff like that, scientists from back in the day, where it's like, all right, they seem like one of like, quote unquote, the gods of modernity, if you would. Like, oh, of course, like this is obvious. But you find out during their lifetime, it's like, well, they talked about this, they got made fun of to an extraordinary extent, and they end up dying penniless and alone. And that's a very sad thing, but that tends to seem to happen to some things. And then other people get criticized for whatever, and then you got folks like, I think it was Boltzmann, I think even like John von Neumann, like arguably one of the greatest mathematicians ever, they end up taking their lives. Now, John von Neumann, he was criticized heavily about some personal things about how he lived his life and everything, and nowadays we're like, what the heck are you talking? It seems very a trivial thing to, who cares who somebody loves as long as consenting adults are consenting adults. That's my opinion on that. All right. David Glenn is, okay. So I think, was it Kyle Hill pointed this out. David Glenn's commenting that I block any YouTube channel that has Michio Kaku's picture in the thumbnail. Kyle Hill pointed that out about a lot of the different clickbaity channels. He's like, what you're typically going to see is a picture of Professor Kaku or Professor Neil deGrasse Tyson in there. And it's like, scientists are losing sleep over, or scientists are terrified, blah, 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 blah. And what is it? It's sometimes people might call it AI slop. I mean, you can just take a bunch of stock footage, have an AI thing do a voice. You know what? My thing is, if somebody wants to do that, as long as you're honest about it, I don't really care, as long as you're actually providing interesting information. And heck, I've been on the internet long enough. I remember when Tim Pool still linked to sources in his description. I know. And now I'm watching like Greta Van Susteren going over. It's like, how many journalists are just nonstop saying, sources say, and you don't actually see the sources. It's that whole, you can be a journalist, and if you're going to use an anonymous source, you can do that, especially if it's a matter of national security or something. I totally understand that. But if you are over-relying on that, every time you use an anonymous source, you're borrowing from the public's bank of trust. And if you keep on just running your credibility against the public's trust and you end up not being correct, or it finds out that maybe your sources don't really know what they're talking about, that's how people lose faith in journalism. And I think, unfortunately, that's led to a lot of where we are today, because it's like, well, if you essentially, even if you didn't mean to lie, if you ended up being wrong, so essentially you lied to us, what else are you lying to us about? Oh, no, we were wrong about that, but we're right about this. Why would we believe you? It's a very sad state of affairs. So, all right, let's get back to some science stuff. And The whole point is, of course I expect people to call me crazy. Because it seems like a crazy thing that I'm about to show you here. And ultimately, what do? You look at the source it's coming from. If the source is a rando like me as a dude on the internet, of course you're going to heavily discount it. I mean, I would. I'm just a random person. But if there's one thing I've learned, it's we never know where a good idea may come from. So the opposite of that is, if my name was Professor Ed Witten, which I am not, but if Professor Ed Witten were to present something, or Professor Michio Kaku, or Professor DeGrasse Tyson, if you had those folks presenting more or less the same thing, people are going to give it what's called higher credence, in that you're more likely to believe it because it's coming from an authoritative source. Oh, we've heard that before. Authoritative sources. Well, that always goes well. And again, I say that as somebody that I'm willing to defend a lot of the stuff is out there, because I think a lot of the science that we have is more or less, it's mostly right. It's mostly right. Now, there are areas here where we still don't know about things, and what I find is the scientists that I personally respect most are the ones who'll say, I don't know, or we don't know, or we speculate, or we conjecture. They're letting you know, and if they give their opinion, they're expressing it as their opinion. Whereas you could just say, take one random article and then just completely change it. It's kind of like, what was it, at Cern recently, they turned lead into gold. So you'll see like the headline of like, scientists achieve Newton's goal of alchemy converting lead into gold for the first time in like hundreds or thousands of years. It's like, okay, now that may be a technically true headline. When you actually delve into it, it's like, all right, we created like 27 nanograms of gold for like, I don't know, like 5 milliseconds, and then it evaporated. What does that mean? Most expensive gold ever. That's what it means. So just because you can do a thing doesn't necessarily mean it's practical. So that's why, because right now, as far as we know, like for standard fusion technology, yes, we have netted out positive energy. And apparently, recently, they've netted out a bit more. But is it feasible to power a city? No. Is it feasible enough to power like a standard home? As far as I know, no. So just because you can do something doesn't mean that it's necessarily going to make sense. So it's like, all right, hey, we got rockets. People can go up in space, and if you got a buttload of money, yeah, you can experience some microgravity for a short period of time. Now, does that make it feasible for your standard Sally Dicker Jane to save up for a vacation and be like, we would like to experience microgravity? Sure, for the low price of, I don't know, like $800,000 or $1 million, whatever it is. I'm not sure the magnitude there. Again, correct me on that. But it's one of those things where, yeah, if something is new, yeah, you should be skeptical, because that's science. Because if we have the things that we know, and we know them pretty well, if all of a sudden we're exposed to something that's new or seems different, it's like, well, yes, we should be skeptical. So that's that whole trust but verify, or be skeptical but look into it. Because sometimes I'll see somebody and it's like, well, this person seems like a complete nut job. Maybe they are a nut job, but just because somebody might be a literal like lunatic or something like that, again, I can say that because I'm basically a lunatic, doesn't mean they might not have something interesting to say. So, after bloviating for over half the show, let's get to some comments and then we'll actually jump right in. Okay, where is this? Well, Tommy, I mean, obviously, you had an opinion on a Transformers toy, therefore you are racist. It's kind of like unexplained anomaly in the sky, therefore aliens. Now, that might be the case. Perhaps Tommy is an extraordinarily racist person, or maybe somebody is just saying that because they don't feel like arguing with something. So, again, I'm not saying that there aren't aliens, but I'm just saying that yes, you see some blinking light, you're not sure, therefore aliens, that logic doesn't follow. Okay, because it's like, could it be something else, a satellite? No, why? So I want it to be this way. And a lot of people, that's one of the things I also learned from sales, because if you say something with confidence and conviction, that's going to help people believe what you're saying. Why? Because you're seeming authoritative. So it's like, I could come up here and say, I've solved the hierarchy problem. Obviously, the God particle is achieved by multiplying the Planck mass by the root of action. It's actually obvious, and it's trivial because it's within 4 megaelectron volts of the most recent measurements. I can come out there and say it directly like there with sheer confidence and conviction. Now, I don't know that. So that's why I typically don't go out there and say that. Why? Because, well, then you're just leaning into kayfabe. Kayfabe is something from the business of professional wrestling where you're playing a character. And at least, again, that was why I got out of the political sphere when it's like people saying, oh, look at this terrible, horrible, no good, very bad person. All right. If you basically need to rip off a children's book like Alexander and the Terrible, Horrible, No Good, Very Bad Day, and you have to put all those adjectives in, is somebody actually telling the truth, or they're just kind of giving their bit and jive on an opinion? Just something to think about. Oh, yes. Yeah, Tommy, we are cray-cray. All right, let's see. Okay. David is commenting, the two great hard problem of science is consciousness. How many glasses of water per day a person is supposed to drink? Listen, man, there's plenty of folks out there thinking about consciousness. I don't know. That seems too hard for me. Why? When it comes down to consciousness, you got to figure out human beings. And when it comes to figuring out stuff about human beings versus figuring out maybe fundamental reality, I feel like fundamental reality is easier than people. Because people, we're too complicated. That's my take. So, hey, Sandro. Yeah, I got your email. I need to double check your schedule. Maybe tomorrow, like afternoon, maybe aroundish this time or something. And if you want to come on, I can send you a link and we can go through your stuff. Okay, so the interview with Demystify Psi. I was talking about paradigm drift. So let's actually go to that real quick. So if anybody does have an idea, including yourself, Sandro, it's an opportunity. I think also Bill from the Theories of Everything Discord from Kurt J. Mungel's one. I think he had put his name in the hat. So what they do is, let me just bring this up. Okay. So channel and, all right, video. All right, so let's present this. Share screen, tab, channel. Okay. So this was actually my second time, thanks to Anastasia and Shiloh. So what they do is they have a monthly program that they'll do. The next one is actually going to be live from Sembra, Portugal. I'm going to be there with another colleague. So if you're not attending the conference, that's okay, because the next one will be held, I think, probably early July. But basically, they'll have a sign up on their website, and you have something like this. So it's like,
all right. Matthew.
Oh God, hold on. I had it on 144p. There we go. All right, so what they'll do is they'll have usually a couple of friends either in studio or around, folks that they happen to know, to give feedback. And then what you do is they'll give you 60 seconds if your name is chosen. You just hop on, they'll give you permissions on the Zoom call. You can basically then pitch over 60 seconds your idea, and then they'll interview you for like maybe 10 or 15 minutes about it and everything. So
let's count Matthew in here. Let's give him actually, did we give Matthew a round of applause?
Oh yes, people are cheering. Okay. So long story short is let's go to the description. So the folks over here, Anastasia and Shiloh, it's the Demystify Psi podcast. And then basically they'll do the episodes of, I think they have starting a paradigm drift here. So yeah, right now it's Tuesday. So Thursday they should be coming out with a full episode. But for here's now, what they have. Yes. So they got at least the first 2 episodes right now here. And what they'll do is they'll interview maybe like 10 or 15 people, however many folks they have time for, probably about 8 to 10-ish realistically. over the course of about 2 hours, and they'll go through their different ideas and share different stuff and things over there. So, yeah, it's an opportunity if you have an idea, and even if it's out there or something, hey, you can feel free to share it. They've had all different types of crazy ideas or something like that, but you never know what might actually turn out to hold water, so to speak. So, hey, Keisho, good to see you. Good to see you. Okay, so tomorrow you work. All right, that's no problem. I'm probably going to be heading out from the monastery probably the beginning of next week. Right now, I got to catch a flight and pick up a car in a different state because of a series of unfortunate events. Yes, I'm quoting Lemony Snicket right now. I thought that was the Van Bellen Sebastian when I saw the thumbnail. Actually, it's Secretary of Nature is actually Shiloh and Anastasia's band. They're over in Oregon, and so they'll do different shows often on like the West Coast and stuff. So I'm not sure where everyone's at. Rosalia is commenting, consciousness is a quantum mechanical reality. Well, I think Professor Penrose might be of that persuasion there, and there's some very interesting research with superluminescence within tubulin that apparently a lot of people weren't expecting, but seemed to be found. But Professor Penrose, being a good scientist, he said it's an interesting result, but it doesn't prove like what he was conjecturing. Now, he could have just come up there and said, well, yes, this is evidence supporting what I'm believing. He's like, I'm basically neutral to it because he, him and Stuart Hameroff had proposed, the ORCA theory, or the orchestrated objective collapse theory, where that something about the collapse of the wave function, or however you want to think about it, helps lead to consciousness. Now, I have no idea, and again, that's why I kind of stay away from consciousness, because it's like, am I conscious, or am I just kind of responding to my surroundings, just kind of like, I don't know, a cat, a dog, a guinea pig? I mean, you have a bug, if you start like poking at a bug, the bug's probably gonna go the other way because it's terrified because some gigantor is poking at it and stuff. So are we just reacting? Are we players within some ginormous game of reality like Dr. Tom Campbell, or excuse me, Mr. Tom Campbell has conjectured? I don't know. Yep, Secretary of Nature. Exactly. Chaos versus determinism. Listen, some people will say there's free will. Others will say that there is not. All I know is, as much as I love advertising the Mystify Sci podcast, we don't need to see all their shirts and stuff the whole time. You need to look at my Pooh Bear shirt instead. I digress. But, listen, I don't know if there's free will or not. If there's no free will, then destiny it is. Hey, whatever, I'll take it. Okay, so after about 40 minutes of beating around the bush, let's actually get to what we're talking about. All right, why is the mass of the Higgs boson so much smaller than the Planck mass? All right, ginormous discrepancy. Let's show the actual discrepancy, so I don't have to take my word for it. All right, so let's take the Higgs mass and divide it by the Planck mass. Again, I'm not a paid spokesman for Wolfram Research. Full disclosure, I'm attending the summer school. Or at least that's the plan. All right, so as we can see, it's 10 to the 17 times smaller. It's ridiculously small. Hold on, let me just double check to make sure I have those numbers. I think it's 10 to the 9 GeV. Hold on, I need to do C squared to get the Planck energy. All right. What is it? Where's GeV? More. Okay, I was off by 10 orders of magnitude. All right, that's why it's 10 to the 19 GeV. I was thinking of in joules, it's 10 to the 9. All right. So that's why I was off. All right. I'm like, 100 million times? No, it's a lot more than that. Yeah, it's 10 to the 19. All right. So that's what makes it more of a puzzle, is why the heck is this 10 to the 19 GeV, and this is like 125. 17 orders of magnitude difference. All right. So while playing around on Wolfram Alpha, and taking some intuition from alpha, the fine structure constant, there's something that you notice. And one of the things here, I'm going to write down a bunch of stuff, don't worry about it. This is just how we define alpha, what we colloquially call the fine structure constant. It's that dimensionless number that's close to about 1 over 137. So like the whole Rick and Morty, it's Rick Sanchez, the main protagonist, is from universe 137. Ah, pop culture, you see. All right, so the whole fine structure constant, alpha. Oh God, that's a funky looking alpha. God, I need penmanship. Penmanship and spelling were my worst subjects. All right, so we got our little fish alpha is defined as, you got this E squared, so that's the charge of a proton or electron. They're equivalent, but opposite charges. So you get positive and negative to our understanding, or at least convention. If you square a negative, you're gonna get a positive. So that's why this kind of makes sense. Okay, so we get elementary charge squared over 4 pi epsilon naught, which is the electric constant, times the speed of light, times the elementary unit of action, hbar. This is what it's defined as. Now, perhaps you can get an intuition for this. For me, I'm like, I don't know, so a square charge divided by a circle, the electric permittivity of free space at the speed of light via the minimum unit of action. I could try to think of something what that is, but then we use a little intuition. Now, most of this just came from Wolfram Alpha and it told me, but this is a dimensionless number. Now, all these things here, except this 4 pi, which you can think of kind of like a sphere, these all have dimensions. So that means that this is charge squared, and it's going to cancel out to something that's dimensionless. So that means that all this whole crazy thing here must end up being charge squared as well. And then when you go through the stuff, you end up realizing that you can rewrite this whole thing on, let's say, computationally reduce it to a much simpler definition or notation. So you can just change this whole thing to elementary charge over Q sub P, which is the Planck charge, and you square that whole dang thing. Huh. So, at least for me, now, and again, this is nothing new. There are people that have known about this. I've watched, was it John McElner? There was some physicist on with Fractal Woman. I should probably actually link that, where he presented this to her, and she's been really big on units. Shout out to Fractal Woman. And one of the things you realize is, well, wait a second, that whole dang thing is basically just a Planck charge. So it's like, wait, so you have elementary charge over Planck charge squared equals the fine structure constant. All right. So again, let's just share with the class. So let's hopefully Wolfram Alpha servers are not being heavily bogged down like they were the other day. So let's just do this. All right. So first, let's just type in alpha. So it's going to give us, we want the unit. Okay. So here's what we have here. So this is alpha, the fine structure constant. Its approximate value is this. Some argument once you get to the last digit, but that's, we'll pass over that for the sake right now. So that definition is the whole thing that we have on the board there. E squared 4 pi c epsilon naught h bar, yada, yada, yada. Okay. So let's try to simplify this. So let's just do elementary charge divided by the Planck charge. Square the thing. Oh, look. This appears to be the same number. Huh. 0.007297352556. 0.007297352556. Oh, it seems to be computationally equivalent. Imagine my shock. Yes, that's a charge pun. All right. So having that as a bit of knowledge, I decided, I'm like, well, what happens if I did something similar? So let's go back. We had oh, you gotta reshare, sorry. Pardon. So again, this is basically just thanks that I could go through this so quickly with a free website. Now, full disclosure, I happen to pay because I have the pro version, just a little bit more computation time, and Wolfram Research doesn't have a Patreon, so we got, all right. So why is the Higgs mass much smaller than the Planck mass? Let us attempt to do science. We just asked the original question, so we have Higgs mass or the Planck mass. You get that 10 to the 17 number. I have no idea what that is. So, but I don't know what that is, but if I'm going to take some intuition from the fine structure constant, what do we have? We've got an elementary thing divided by a Planck thing squared. So I decided to do just that. Just throw our little protective brackets around it, we square it, and then we get this number here. Okay. Now, most folks, this number 1.05 times 10 to the minus 34. That shouldn't mean a dang thing to anybody. All right. Because also, if there's one thing I've learned from Sean Carroll, it's all good physicists set h bar equal to 1. And in one of his videos, he even says, like, if you ask me the value of what h bar is, I don't know. Because all good physicists set h bar to 1. Since I'm not a good physicist, and I don't usually set h bar to 1, unless in the particular case, I recognize at least the first 3 digits and this magnitude. This happens to be the first 3 digits and corresponding magnitude to, let's go over here, h bar. Make a new window. So we just literally type in h bar, the elementary unit of action, which, let's, more digits. So as we can at least see here, the first 3 digits are 1.05 times 10 to the minus 34. Now, again, it has dimensions there, but that's a very interesting thing. It's like, wait a second, it's got the first 3 significant digits and the correct corresponding magnitude to the elementary unit of action. Huh. Okay. For those that have stuck with us, we're getting to the punchline. Okay. So I looked at that, I'm like, what if I assumed this was true? Because one of the things that Thad taught me is he had his equation that somebody sent to him. He changed the algebra a little bit. He's like, well, this seems to get the fine structure constant for like 6 significant digits. He's like, this is better than anything else I've seen. So what if I assumed it was true? What would I have to do to make it right? So he's solved for y. And then he got the correct magnitude in the first digit or so of the Planck mass. Plug it in, it's like, oh, this seems to be within about 1 sigma of the best measurement at the time. Who would have thought it? So all we do is, if we assume there's some there, then what we can do is, all right, well, let's set this equal to. So since this is a mass, and we're dividing a mass, this is going to give us a dimensionless relationship. So we're going to take h bar, the elementary unit of action, and we're going to divide it by its reference of action, which is the Joule second. Where do I get that from? Well, it literally says it here. It's expressed in units of energy seconds. So that may seem arbitrary, but is it really arbitrary? Because, well, if this number isn't arbitrary, and it's literally in reference to this, well, if this is arbitrary, then this is arbitrary. And we use this all the time. We literally consider this a 1 within our system of measure. Huh. And this is just a reference 1. See, that was part of the argument that we need to make a little bit better. So what I'm doing is I'm taking this number, I'm dividing it by this number, and let's actually see what happens when we get that. Okay, it's giving us the dimensionless number. And let's do this. All right. So we've got these things here. We're going to assume it is equivalent to the magnitude of action. So all we do is, the Planck mass is defined. We get about 5 or so significant digits of confidence in there. We got 7, but there's error bars. So let's literally just solve for x, just like that did. X, and this is in kilograms because it's a mass. So we just solve for x. Go through here, it does the mathematics and stuff. You get this number here, okay. So this number here, and note, it's interesting because it does actually give us a positive and negative solution. So perhaps that's significant, perhaps it isn't. I'm going to include the different versions in the paper. But, so this is kilograms. So we're just going to attach the kilograms that we solve for. So we get this magnitude in kilograms, which is, oh, lucky. That seems to be about the mass of the Higgs boson. Well, that's interesting. But again, that's only 3 significant digits. All right. So if we did our little energy conversion, we do the c squared. We're going to get, all right, about 125.37-ish GeV. All right. To be fair, this actually ends up being, it does give more digits. All right. It actually comes out to be 100 and, I'll give you if you throw in all the units from CODATA and everything, you're going to get, let's pull this down. So we're going to get about 100 and, I'm going to get 125.376. And there's going to be an error of 2. So I'm putting the little error bars here. There's going to be a 2 there. So that means this 6 could flip up to an 8. It could flip down to a 4. Okay. Because that's our uncertainty in the Planck mass. Because that's what we're setting as. It's a base that we're kind of essentially referencing it by and then setting it equal to that hbar magnitude. Okay. And this is GeV divide by c squared because we want to be accurate. Okay. So we have that little relationship, and then, but wait, there's more. So if we use the Eugene notation, shout out to Eugene the philosopher, we follow each other here on YouTube, and he had pointed out, now maybe Thad had written it down before, but he was the one that really hit in my head about how you could express this in another way. So because some folks might say, oh, you can't set it equal to that, that doesn't make sense. Fine. Okay. So what you can do is, we can, again, computationally reduce it. So again, we're going to take hbar, the elementary unit of action. The big thing that they say is, oh, when you see hbar, we're talking about quantum mechanics and all that small stuff. Cool. That's totally fine. We're going to take hbar, the elementary 1 of action. We're going to divide it by the Joule second, the reference of action, and then we're going to take the square root of it, aka we're going to be taking the root of action. You see what I did there? All right. So we're literally taking the root of action, and it gets us about 10 to the minus 17. Wait a second. Wasn't that the relationship difference between the Planck mass and the Higgs mass? Well, let's just see. Let's just multiply it by the Planck mass. Oh, lucky. So again, that's of the magnitude of the Higgs mass, 125.38 GeV. Now, why might that be an interesting number? Okay, let's go into why that might be an interesting number, because if we go to Cern's CMS Collaboration, shout out to them because they actually won the Breakthrough Prize recently. So if we take the most recent CMS, the compact muon solenoid physics analysis summary for the combined measurements of the Higgs boson. Okay, so right now, the best fit has the mass of the Higgs boson to be about 125.38 giga electron volts. What do we have over here? Oh, 125.38 giga-electron volts. That's interesting. Now again, the actual number that we get is when we put in all the most recent stuff from CoData, it's actually not, it rounded up to 125.38 giga-electron volts. But right now, we do this notation of literally, I'm just taking the elementary unit of action, hbar, we're dividing it by the reference of action, the Joule seconds. We're taking the root of action there, and then we multiply it by m sub p. We're going to get, so the whole question, why is the Higgs mass so much smaller than the Planck mass? It's 17 orders of magnitude difference. Who ordered that? Well, maybe the root of action did, because right now, if it's getting that, and our most recent measurement is from CMS, that's equal to 125.38 GeV divided by c squared, because it's a mass. All right. That means that our difference, and again, I'm not great at math or anything, but even I can do this. We match for 1, 2, 3, 4 significant digits, and then the fifth. Well, to be fair, this ends up being a difference of 4 MeV mega electron volts divided by c squared. So it's literally off by a mega electron volt is 1,000th of a giga electron volt, because at least when I remember from being educated at state school is once you get to the decimal point, we have the tens, the hundredths, and the thousandths. So we literally need to go into the thousandths of giga electron volts to see the difference. So it's within about 2 sigma of that estimate there. And again, here's the thing. There have been measurements at or around this, but at least for me, and again, could be completely wrong, and again, this might not be anything at all. It might just be a very interesting coincidence. But when you look at the measurements, it's like, all right, 126 GeV, 125-ish, and so the measurements seem to be kind of clustering around this area. And as Vanessa from the monastery said, nature is simple. Might, rather than having to add all these different amplitudes together and then all these correction factors, this, that, and that, the difference between the Higgs mass and the Planck mass is literally the root of action. That can't be right. That would be too simple. We need lots more notation. We need lots of crazy things here. And again, some rando can't figure this out. I mean, that's heresy. Well, heretics Inc. it is then. So again, now I actually need to finish my paper, and because at first I'm like, I didn't even show that 6 before, because I'm like, the last measurement was 125.35. So now it's like, all right, let's just put what's out there. We'll see how the predictions go, and let's see where the future measurements go. And maybe it's completely off, but this does match the magnitude of hbar now for 4 significant digits. If we get one more, at that point now we've run out of actually known digits in the Planck mass. So I think it might be something that's a lot harder to ignore in the future. So again, might not be anything. This is our PB&J conjecture. Why? Because who doesn't like PB&J? And again, I realize some folks have nut allergies and stuff, but it's a cool little quip. And if it ends up being some there, it's going to be a lot easier to remember for anybody that needs to be taught or learn it or something. Because we should make things easy. We should make things fun. Why? Because that's how people learn. If you're just up there and you're on blah, 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 don't get me wrong, some people are all right with that, but I start snoring and stuff. Great teachers make all the difference. I ain't a great teacher. I'm just a dude on the internet that's wildly conjecturing, and most of the things and holes I go down are completely bunk, don't mean everything. But every once in a while, you might find something shiny, and maybe it's fool's gold, maybe it's a real nugget. So, I don't know. But hey, Chris, good to see you. Good to see you. We're gonna see. I'm gonna be. I think this weekend I might be able to pop in for maybe the weekly roundup. I'm probably gonna be. I was thinking about traveling at the end of the week. I'm probably gonna travel at the very beginning of next week to make my way back to the East Coast after a series of. Oh, actually, you might be in Iowa. My car was broken down in Des Moines or Urbandale or wherever it is, just outside of Des Moines. I'm going to be going back there at the beginning of the week. I have no idea what your schedule is or anything, but if you want to grab like some breakfast or some lunch or something, totally love to. So Mills is commenting. Hey, the title caught my attention because it articulates my motivation for diving into biosemantics and panpsychism. Okay. That's why I also don't talk about consciousness, because I always have to start off with panpsychism aside. If consciousness is built in, that would explain a lot. I play around with some numbers and everything and try to conceptualize what might be going on, because the consciousness stuff it's over my head, literally. I'm at least, if I do a calculation, I can try to gain an intuition for it. And if we have strong agreement with experiment, then maybe that's worth sharing. Because I could also speculate saying, what is it? We'll end there. We'll end there. We've already committed enough heresy for right now. So that's a great compliment. And again, we don't know if any of this stuff just could be this is literally just numerology right here. But numerology is numerology until it explains more with less. So maybe it's more efficient to run integrals and add up all this summation to try to cancel out, to get it up to the Planck mass or energy or whatever you want, or I don't know, maybe the difference is literally just the root of action. So is it Occam's razor? I can't say. We're going to have to follow the evidence, because if there's one thing I learned, I'm not an attorney, but my old man, God rest his soul, he always told me, he's like, Memes, you follow the evidence, because the truth is the ultimate defense. I'm not saying this is the truth. I'm just saying we should follow the evidence, and perhaps this is something worth entertaining. But with that, exactly. Dude, I learn stuff from folks here all the time. That's the great thing. It's like some folks, they like to hide. And it's like, all right, I don't want people stealing my ideas. I'm like, if you put something on the internet, everything is time-stamped and dated, right? So, like, if somebody steals your idea and they put that out there and they try to claim it for themselves, it's like, all right, was this out there first, or was it maybe that it was listed there 6 months before other people started to try to take credit for something? So I'm like, the internet is a great tool for at least documenting thoughts and ideas. So, but with that, I'll leave you all. Peace out, everybody. It's a wacky and wild world out there, but I was hoping for